any element box on the periodic table, there are two predominant numbers. One of them is a whole number, the other one's a decimal. The whole number is the atomic number, the number of protons in any atom of that element. And the decimal number is actually something called the average atomic mass. If you remember, the mass of an atom comes from the nucleus, and the nucleus is composed of protons and neutrons. Both protons and neutrons have a mass of 1 AMU. So how can the average atomic mass of an atom be a decimal if the subatomic particles that make up the nucleus of the atom all have a mass of 1? The answer is isotopes. If I have a sample of an element, all the different isotopes that exist are in that sample. So to get a mass, I want an average of all those isotopes. I have to use the abundance of each isotope and the mass of each isotope to calculate an average atomic mass. This is best seen with an example. So let's use carbon as an example. Carbon atoms make up the diamond in this ring. Most of the carbon atoms in the diamond are actually carbon-12 isotopes, made up of 6 protons and 6 neutrons. 1.109% of the carbon atoms are carbon-13 isotope. They have 6 protons and 7 neutrons. An even smaller percentage of the carbon atoms are carbon-14, made up of 6 protons and 8 neutrons. So if I want to find the average atomic mass, I need to take the abundances, and I need to take the mass numbers, and that will allow me to find the average atomic mass that you see on the periodic table. To do this, the first thing you want to do is take those abundances in percent and change them into decimal form. You divide by 100 to get that done. So 98.89% is 0.9889. 1.109% is 0.01109. And 0.001% is 1 times 10 to the negative fifth. I'm going to take those decimals and multiply by the mass number. And I'm going to add those up. So I'm going to take 0.9889 times 12. I'm going to take 0.01109 times 13. And I'm going to take 0.00001 times 14. And I'm going to add up those products, and that should get me the average atomic mass that you see on the table. I encourage you to get your calculator out and do these calculations along with me so that you can get practice at doing these type of problems. So I'm going to do these products, and I'm not going to round. I'm going to save rounding till the very end. If I get that first product, I get 11.8668. The second product for carbon-13, I get 0.14417. For the product of carbon-14, I get 0.00014. If I add those 3 products up now, I get 12.01111. Now when you do these problems, I always want you to round the atomic mass to the hundredths place, to 2 decimal places. So you keep all your numbers till the very end, and then you round to 2 decimal places. So for this, I'd get 12.01 atomic mass units. And what do you know? That's the exact same atomic mass as you get on the periodic table. That's the beautiful thing about these problems. You'll actually be able to check your work, because when you get done, you should get the answer that's actually on the periodic table. If you didn't, you did something wrong. Now, they may be off by just a little bit. That's okay. But if you get something drastically different, you did the problem wrong. Let's look at another example. We'll be a little bit more specific this time because the actual mass of a proton is 1.007276 atomic mass units. And the actual mass of a neutron is 1.008665 atomic mass units. So how do we get the average atomic mass for nitrogen that we see in the table? Nitrogen has 3 isotopes. One of them is totally insignificant. We can ignore it for these calculations. That's nitrogen-13. Most of the nitrogen is in the form of nitrogen-14. Now the actual mass of nitrogen-14 is 14.003074. Okay, the remaining nitrogen is the isotope nitrogen-15. And you can see nitrogen-15's actual atomic mass right there. So we're going to take these abundances and convert them into decimals. So divide by 100, we get 0.99632 and 0.00368. I'm going to take those abundances and the actual masses of each isotope, do a little magic, and I should get that number that's in the periodic table. So I'm going to take my abundance for nitrogen 14 and multiply by the mass of nitrogen 14. I'm going to take the abundance of nitrogen 15 multiplied by the mass of nitrogen 15. When I add those together, I should get what's in the periodic table. My first product is this. I'm not going to read that. That's a lot of numbers, but I'm not going to round to the very end. For my nitrogen 15 product, I get that small number. When I add those two up, I get 14.006744309. Now I'm going to round. I'm going to round to 2 decimal places, the hundredths place. When I do that, I get 14.01 atomic mass units, which is the exact same atomic mass you get in the periodic table for nitrogen. It's magic. Now it's your turn to practice these problems. If you follow this procedure, you can't go wrong. Remember, you can always check your answers by simply looking at the periodic table. Good luck.